Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to look at another example of maximum and minimum problems. So here, a man launches his boat from point A on a bank of a straight river 3 kilometers wide and wants to reach point B, which is 8 kilometers downstream on the opposite bank as quickly as possible. So first of all, let us start by visualizing this statement. So we have a straight river, not quite straight. So let's say we have this straight river. Okay, much better. And so this river is 3 kilometers wide. 3 kilometers wide. So this man is launching his boat from point A. So launching his boat from point A, and which is 3 kilometers wide, and he's going to reach point B, which is 8 kilometers downstream on the opposite bank, which means this is the opposite bank of A. The point here is 8 kilometers downstream, could be on this point. So this is point B. So the distance between that point and this point is 8 kilometers. Okay, now he could row his boat directly across the river to point C and then run to B, or he could row directly to B, or he could row to some point in between B and C, we call it point D here, and then run to B. If he can row at 6 km per hour, so this is the speed of rowing, and this is the speed of running at 8 km per hour, what would be his best strategy to reach B as soon as possible? So he wants to be there as soon as possible. So this is the problem of minimizing the time taken. So minimizing time. Okay, so assume that the speed of the water is negligible compared with the speed at which the man rows. Now what it means is for this last statement here, well, you know, if you have a river, so if you are there is a current, so current is going in this direction downstream. So if a person tries to row the boat across this river, the current here will act on it, and the speed of it will be affected. It cannot be at 6 km per hour because the speed here will be affected by the current of the river here. But when it says that assume the speed of the water is negligible, that means the current has no effect on the speed of rowing. That means the speed of rowing is maintained at 6 km per hour as it says here on this example. Okay, so there is no effect of the current here. Okay, so now based on what you have seen so far, we understand that there are three options for the man to reach point B from point A to point B. So the first option is, I'm going to write down the first option. The first option is he's going to row the boat across the river to point C, so directly across. So that means it's going in this direction, directly across. So this is called point C. It's going to row the boat to point C, so from A to C. So he's going to row from A to C. Now the distance is going to be 3 kilometers. I'm going to write down all the relevant information related to his option. So row A to C, so the distance is 3 kilometers that he needs to cover, and the rowing speed is 6 kilometers per hour. Once he's done that, he's going to run from C to B. So he's going to run from C to B, and the distance that he needs to cover is 8 kilometers, and he's going to do that with a speed of 8 kilometers per hour. So that's the first option. So he's going to and then run to B. So how about the second option? Okay, so the second option is option 2. He's going to row directly to B. So he's going to reach point B straight away by rowing. And so he's going to row from A to B. And the distance that he needs to cover, we don't know yet, but we can find out. So I'm just going to label that with D. D is a distance. The distance that he needs to cover is can be found by taking the Pythagoras theorem. I hope you can notice that this is the right angle triangle. So the distance is going to be 3 squared plus 8 squared. Okay, so that's the distance. And so that will give us 9 plus 64. The square root of that is, so this is going to be 9 plus 64, which is just 73. So 73, and this is approximately 8.544 kilometers. And he's going to do that with a speed of 6 kilometer per hour. So the speed is 6 kilometer per hour. Okay, now the last option. Okay, the last option is option 3. So this is the third option. He's going to row from A to D. So D is a point in between. We don't know what or where D is. So let's say this is somewhere in between. So this is point D. And again, the distance can be found. Okay, so this is the distance of rowing from A to D. Okay, so again, you can find the distance here. I'm going to call the distance as y. Okay, let's say this is y. So the distance is going to be y equals to, I know that the length here is 3 kilometers, so this is 3 squared. For this one, I don't know what is the length, but I can call it x. I don't know, and I can call it x. So this is going to be x squared plus x squared. So this is the distance. In this form, we cannot simplify that anymore. Okay. So now the speed of rowing is 6 kilometer per hour. Next, after he reached point D, he's going to run from D to C. Now the distance of running for this point to this point is going to be 8 kilometer minus x. So x is a distance from C to D. Again, x is a distance from C to D. So if I know what x is, I can tell that the distance from D to B will be 8 minus x kilometer. And he will be doing that with a speed of 8 kilometer per hour. So basically, that is all the information that you can get from this example given here. Now let us look at the time taken if you decide to go with option 1. If he decides to go with option 1, okay? So if he decides to go with option 1, you can see that, okay, what is the meaning of this? This is the speed. So basically, when it says 6 kilometer per hour, it means that you can cover the 6 kilometer distance in 1 hour. So that's the meaning of that. And if you have 3 kilometers clearly from this simple statement here, therefore, of course, if you have 3 kilometer of distance, then you will be able to cover that in half an hour, which is 30 minutes. Okay, so that's the time taken to cover the 3 kilometer of distance. Now for this one, it means that you can cover 8 kilometer of distance in 1 hour. So that's the speed of running. Therefore, since he needs to cover 8 kilometers of distance, the time that he will take to run and 8 kilometers of distance is going to be 1 hour. 1 hour. So therefore, the total time for option 1, so option 1 here, total time is going to be 1.5. Okay, so total time is going to be 1.5 hour. Okay. Now, if you look at the second option, okay, so second option, we can see that the distance here is 8.544 kilometers. Okay, and again the speed is 6 kilometers per hour. So if 6 kilometers can be done in 1 hour, then what is the time taken for 8.55 kilometers? So now for example, you can construct a simple ratio. So 6 kilometer can be done in 1 hour. So how about 8.544 kilometer? How many hours does it take to to row the boat from A to B, where the distance is 8.44 kilometer? Therefore, x is just going to be 8.544 over 6, and the answer is going to be 8.544 over 6. So the answer is going to be, it takes about 1.42 hours. Okay, so total time is 1.42 hours. Now if you still confused with what's going on here, I hope that you do remember that speed is just distance over time. This is distance over time, because you can see that this is the distance, this is time in hour. So if you want to know what is the time taken, so therefore time is just going to be distance over speed. So this is the formula that relates the speed, time and distance, and this is going to be useful as well. So you can actually apply this formula to find out the total time for option 1 and the total time for option 2. So that's another way of solving what I've shown you just now. Okay, now for option 3, okay, so for option 3, we need to find the time taken to row from A to D and to run from D to C, and this is going to be constructed using a mathematical function. So we need to construct a mathematical function first. Okay, so based on this, based on what we have done so far, what we know about time is time is generally time taken to complete this is generally time for rowing plus time for running. So what we have done so far is we take into consideration for option 1 the time taken to row the boat and the time taken to run. For option 2, since he just rows the boat straight to point B, so this is just about the time taken for rowing. But for option 3, we have time for rowing and time for running. So again, time for rowing, we can think about it as the distance of rowing over the speed of rowing, plus time for running is the distance that he runs, the distance for running over the speed of running. So this is based on this formula here. So time is distance over speed. So now therefore I can write down that T is equal to according to the distance of rowing. This is the distance of rowing. I'm just going to plug this into the formula here. Okay, and the speed of rowing is 6 km per hour. So I'm just going to write down on the bottom. So that will be T is equal to 9 square root of 9 plus x squared over 6. So that is related to rowing. And plus the distance for running is 8 minus x, and the speed is 8 km per hour. So we're going to substitute that. So we have 8 minus x over 8 kilometers per hour. Okay, so this is the formula that we have with respect to time, and our objective is to minimize the time. So we want to find the value of x such that the time will be minimized. Okay, the value of x. So now, in order to do that, we need to differentiate this function with respect to x. So I'm going to differentiate t with respect to x. Now 1 over 6 is a constant, so we just leave it to the side. Now I'm going to differentiate this guy over here, and this is actually 9 plus x squared 1 over 2. Okay, so by doing that, it is easier to actually see 1 over 2 can be brought forward. So 1 over 2, okay, 1 over 2 will be brought forward. So so this one will be maintained as it is, so it will be 9 plus x squared, and the power on the top part is going to be 1 over 2 minus 1, so that will be negative 1 over 2. Next, we have to differentiate the inside here. The inside here will be differentiate 9, you will get 0. Differentiate x squared, you will get 2x. So that is for the first one. Plus 1 over 8. This is 1 over 8 is a constant. You put it outside. And then you differentiate 8 minus x. The answer is going to be negative 1. Okay, so what else? You can cancel 2 on the top here with this at the bottom. And next you can simplify the look of this. So the look of this is going to be x over 6. X over 6, 1 over square root of 9 plus x squared. Okay, so this is the form being simplified, and this is going to be 1 over 8. So this is minus, okay, minus 1 over 8. Okay, in order to find what x is, the value of x such that the function will be minimized, we need to set dt dx equals to 0. Okay, so dt dx is equal to 0. Therefore, x over 6, 9 plus x squared, the square root of that will be equal to 1 over 8. And next we can have x over 9 plus square root of x squared will be 6 over 8. And this is going to be simplified as 3 over 4. Okay, so next I have 4x is equal to 3, 9 plus x squared, so square root of 9 plus x squared. So in order to get rid of square root, we can introduce this. Okay, the whole thing on the equation has to be balanced, so introduce that on the right hand side and the left hand side. So this becomes 16x squared. 3 squared will be 9. This one will be eliminated, the square root sign, so you have 9 plus x squared. Okay, so next what you have is you will have 16x squared minus 9x squared. So you have 16x squared minus 9x squared is equal to 81. 16 minus 9 is 7. 7x squared is 81. X squared is 81 over 7. So x is plus minus 81 over 7, square root of that, and that is just plus minus 9 over square root 7. So x is a distance. Since x is a distance, since x represents the distance, okay, so we're going to see what x is again. So recall that x is this guy here, so this is x is the distance, therefore x cannot be negative. Okay, so therefore x cannot be negative, and the final answer is therefore x is equal to 9 over square root 7. So x cannot be negative because x represents a distance, so we can just ignore the answer where x is negative and we just focus on the value of positive x. Okay, so that is the answer. The distance is 9 over square root 7. So if you want to check what is the time with respect to having x equals to 9 over 7, you can substitute that into this function. Okay, you can substitute that into x, and you will find that the time taken is going to be, so I'm just going to write down the answer here. I will leave it to you guys to check the time taken. So by substituting x equals to 9 over square root 7, you will see that the time here will be about 1.33 hours. So by far this is the shortest time compared to what you have seen here, because total time here is 1.5 hour, and this one is 1.42 hours. But by substituting x equals to 9 over 7, you will get that the time is 1.23 hours, which is the most minimum time taken. So this is most minimum time taken can be achieved. So his best strategy is by doing most minimum time taken is this one. So therefore the best strategy is to row from point A to D, from point A to D, where D is I'm going to write down. So the best strategy is to row from point A to D, where the distance is D1, and that is equal to D1 is, sorry, the distance is y. I'm sorry, so the distance here is y. The distance here is y. Where the distance here is y, where y is equal to 3 plus, where y is equal to 3 squared plus x squared. So 3 squared plus x squared, which is 9 plus x squared is 81 over 7. And the distance is y is equal to 9 plus 81 over 7. So that's the distance. And then running for another distance of 8 minus 9 over square root 7. Okay, so that is the answer to this example here. I will leave it to you guys to determine what is the value of y here. I'm sure you will be able to do that. Just plug in these values into your calculator, and this one also can be determined. What is the distance of running that he has to take in order to reach to point B from point D. Okay, that's all from me. Thank you very much for watching. Have a nice day.